Hello everyone. Now I'm going to discuss another paper about common ownership and environmental corporate social responsibility. The author of these papers are Hirose and Matsumura. They published the paper in Energy Economics in 2022. So this paper is a B plus journal. So these are the outline of this paper. In the first section, we will introduce the paper. In the second, the model. In the third, analysis. And the last one is the concluding remark. So this is the introduction. Actually, climate change is one of the most serious risks confronting society, and reducing CO2 emission in an increasingly important policy issue. So the basic policy of reducing CO2 emission is the introduction of market-based instruments such as carbon emission tax or tradable permits. We can see in PGO 1932 and so on. So actually the environmental corporate social responsibility is about caring the environment, because we know that usually the firm produce output, produce emission. So usually the paper consider that produce one output increase one pollution. So that is why some paper discuss about environmental corporate social responsibility, means the government or the firm need to care about the environmental. So corporate activities beyond legal or regulatory requirement are generally labeled as CSR or ESG, environmental, social, and governance. So according to the Governance and Accountability Institute, about 90% of S&P 500 companies publish corporate sustainability reports in 2019. So means that it says that during 2020, there can be a sustainable fund receive about 51 billion in net flows. In 2019, the flows about 21.4 billion US dollar, and in 2018 is about 5.4 billion US dollar. So means that from 2018 to 2021, it's about 10 times increase in the net flows. So meaning it means that corporate social responsibility increase the net flows. Okay, so here the purpose of this paper is investigating how common ownership affect voluntary emission restriction and emission abatement. So this paper introduced common ownership, how this common ownership affects the emission and the abatement. So we can see in the footnote 6, because this study determine or denote about voluntary emission, means that the firm itself voluntarily do the ECSR. We can find the example in footnote 6. Here it mentioned that voluntary emission restriction is widely observed. For example, Keidanren, Japan Business Federation, runs a program of voluntary initiative. Voluntary initiative means that the firm itself has initiative to do to protect the environment. And some Keidanren members firm have voluntarily commit to numerical target of pollution reduction. Moreover, major energy company in Japan such as Zera and Tokyo Gas has recently committed to reducing CO2 further. So so this paper is actually discussing about the firm voluntarily do the CSR. However, in another paper, we can find that actually the government, because government care about the environment, so the government usually impose tax to the pollution. But in this paper, it's the firm itself voluntarily do the uh, environment protection. Okay. So we can see like Hirose et al. 2020 show that profit maximizing firm may voluntarily commit to an effective upper limit of emission to soften competition and raise price when firm face price competition in differentiated market. So our result here is that the abatement level is reduced under significant degree of common ownership, because when lambda here is the degree of cross ownership. When lambda is large, the equilibrium price are close to the cooperative price that maximize joint profit, because when lambda is large, the less competitive the firms are, therefore the price is low, the price is high. So this price is close to the cooperative price that maximize joint profit. However, when lambda is small, the equilibrium price are far from the cooperative price, because when lambda is small, lower because when lambda is small, higher competition. So this can reduce the price. So this price is far away from the cooperative price that maximize joint profit. These authors also show that the common ownership may or may not improve welfare. So it depends on the cost of emission. So actually, because we talk about voluntarily, right? So there's a big question here. A semical question is why firm voluntarily engage in CSR. As I mentioned before, that usually government care about environment, but here firm care about environment. So in the first point, it says that if consumers reward firms for their environmental CSR, then firm increase the demand for their product and thereby earn higher profit. We can see like in McWilliams and Siegel and so on. However, in Graf, Zivin and Small 2005 provide a model in which investors have preference for both financial and social return and can invest in firms that engage in CSR. If in the first point we see that if consumer reward for the CSR, then the firm can increase the higher willingness to pay. However, here, if the firm voluntarily engage in CSR, then we can see that some can invest in the firm who did the CSR. Lambertini and Tampieri 2005 and so on analyze a model with firms having social concern in their objective in the context of strategic CSR developed by Baron. Here, The last is Hirose et al. Find that cooperative CSR2 and industry association enhance CSR activities, and firm may even individually adapt CSR to relax market competition. Okay, so this slide is discussing about common ownership. That common ownership is usually anti-competitive. Anti-competitive means soften competition. So while common ownership soften competition in products or service market and raises price, partial ownership by common owners in the same industry may lead firm to internalize industry-wide externality and improve welfare. Lofes and Vivis 2019, they analyze about the relationship between the degree of common ownership and welfare. Sato and Matsumura 2020 investigate a free entry market and find that common ownership internalize the business stealing effect, and thus moderate common ownership may improve welfare. They also saw that significant common ownership always reduces welfare. Ken et al. 2021 investigate a vertically related market, so they demonstrate that common ownership mitigates the problem of double marginalization. And this welfare improving effect dominates the welfare harming competition reduction effect in the downstream market if the competition among the downstream firm is weak. So because this is about vertically related market means that there is upstream and downstream. So when they have the common ownership, then this can reduce the double marginalization. However, the authors say that no study analyzed the relationship between common ownership and environmental CSR. So we continue to the second section, the model. A quasi-linear utility function, U is a function of Qi and Qj, where U equals to this equation plus numerator. So we can find that numerator equals to I income minus P1 Q1 minus P2 Q2 because we have two goods. So we just substitute numerator here equals to this one, and we can find the demand function in equation 1. Okay, so we assume alpha beta equals to 1 to avoid messy exposition. Firm's emission EI equals to HQI minus XI, where XI is the emission abatement. So EI is the emission. So emission is actually equals to QI minus abatement. So let's say if you produce our QI equals to 100, and we abate, we reduce because we consider that I produce 1 QI will produce 1 pollution. So when we produce 100 QI, then we produce 100 pollution. So actually our emission, because here we have the investment in CSR, so when I want to reduce my emission, so I abate, right? So if I want to abate about xi equals to 50, so now my emission is 100 minus 50 equals to 50. So that's the meaning of emission here. So to meet the commitment of the upper limit, firm I engage in abatement activities. So the highest, the maximum xi equals to this one, h times qi minus ei. And because the pollution creates the damage, so we have the damage here. So, and then as I mentioned before, that if I want to reduce my emission, I need to abate, right? And to abate, I need the cost. So this is the cost for the abatement. And the parameter k and r are positive constant. So here we assume that marginal cost of production equals to 0, h equals to k equals to 1 to avoid messy exposition. Actually, the author says that we obtain similar result without assuming h equals to k equals to 1. Next, here we can see that the profit of the firm is here. So we substitute xi equals to qi minus ei. So actually this is the same as this one. So this term, this profit, hold as long as the commitment is binding. So xi larger than 0. However, when the commitment is not binding, so the profit is equals to P times Q. So common ownership according to Lopez and Fifi's 2019 psi. So this is the objective function of the firm under cross or common ownership. So psi equals to, this is the profit of firm I plus the degree of common ownership and the profit of rival, because firm I own the share of the rival. So lambda is the degree of ownership. So this is the game setting. The first stage is firm I simultaneously choose EI, emission, and in the second stage, after observing action of the first stage, each of the firm I simultaneously choose PI. So this paper is about Bertrand competition. Okay. So I think Bertrand competition is very important in this result, because later we have delta. Delta makes the paper more meaningful. Okay, and then we adopt the subgame perfectness equilibrium as the equilibrium concept. So we solve the game backward induction. We solve from the second stage and then later on to the first stage. So now we continue to the third section, is about analysis. So in the second stage, we given EI and EJ. Each firm I choose PI to maximize the psi. So we can find the first order condition in the second stage. So we can find this is the first order condition, appendix A1. And from the first order condition, we can find the second order condition here. So we can see that second order condition is satisfied for delta and lambda from 0 to 1. So the second order condition is negative. So we solve the first order condition simultaneously, and we can find optimal PI in the second stage. Okay, but because if we do the calculation linearly or explicitly, our PI is quite messy. So now the author didn't put the PI in the paper, but we can solve the PI, and then we can take the first order condition from the PI, or we take the comparative static analysis. Okay, we can find equation 2 and equation 3. So we can see here that increase in emission reduce the price because this one is negative. For all delta and lambda, from 0 to 1. Okay, here is the intuition. Increase in emission decrease the abatement, because we know in the very beginning that if I want to abate my emission, I need the cost. So decrease my abatement, decrease the marginal cost, and decrease the price. So that is why you can find the equation 2. This is the intuition of equation 2. And then because of the strategic complement, decrease in PI induces firm J to decrease its price. Hence, PI is also decreasing in EI. We can find in equation 3. Okay, next we continue to the first stage. Each firm I choose EI independently. So we can take the derivative of psi with respect to E, because in our optimal PI in the second stage, Pj is a function of EI. So we can find equation 4 where derivative of Pi with respect to Pj, this one, is actually this equation. And derivative of psi I with respect to Ei, this one, is actually here. So the second order condition is satisfied. We can see appendix B. So, or we can just substitute the optimal PI in the second stage to the psi. We can solve them by maple. We substitute PI in the second stage to psi I. And then later we can find psi I, and then we derivative psi I with respect to EI. And we take the second derivative, we can find this value. Okay, where we know that derivative of Pj with respect to EI is negative. Okay. So after that we can solve the first order condition of psi out with respect to EI, and then we can find equilibrium in the first stage, equation 5. So here, the author put the superscript F to denote for the first stage equilibrium. Okay, now we come to the first proposition. From equation 5, we obtain the following proposition. Proposition 1. Actually, in the first point, it says that emission under no ownership is higher than emission under joint profit for all delta element from 0 to 1. And the second point is emission is decreasing in lambda if lambda is sufficiently close to 0 or 1. So we can prove this from appendix C. We can substitute lambda equals to 0 into the equation 5, equilibrium emission, and lambda equals to 1 into the equilibrium emission. So we can find this. However, the intuition is that when there is no common ownership, the firms are more competitive. Output is higher, so emission is higher. However, here, joint profit, the firms are more collusive, less competitive. Output is lower, emission is lower. So we can find this implies that the case in which a significant degree of common ownership yields smaller emission than the case without common ownership. In other words, it's impossible that emission level is monotonically increasing in lambda. Impossible monotonically increasing means that actually emission is always decreasing in lambda. And for the second point is, we want to see whether the emission is decreasing in lambda or not. So we take the first derivative of equation 5, emission with respect to lambda, this one, and then we substitute lambda equals to 0 and 1. So we can find that the first derivative is always lower than 0 or always negative. Means that EF is decreasing in lambda if lambda is sufficiently close to 0 and 1. So proposition 2 states that marginal increase in common ownership from lambda equals to 0 leads to smaller emission. This implies that the relationship between EF and lambda is never U-shaped, and a more complicated relationship must exist if the relationship between EF and lambda is non-monotone. Okay, so that's the proposition 1. So we continue to the next proposition. This proposition is about the equilibrium emission is monotonically decreasing in lambda for lambda 0 to 1 if and only if delta is lower than delta star, where delta star is about 0.862. So we can prove this proposition by figure 1. In figure 1, it shows that, okay, this one is delta. When delta is low enough means the more differentiated the product. The more differentiated the product, the less competition, right? So when lambda is increasing means the less competition, right? So here less competition because of the more differentiated the product, and less competition because the more collusive or the more cooperative the firms are. So here we can see that emission is reducing, which makes sense, right? Because the less competition, the lower the output. So emission is lower. However, here we have delta is equals to 9/10. Delta is 9/10 means that the higher competition because the product is more homogeneous. Okay, so we can see here that the relationship between emission and lambda is non-monotonically, but we can see that the relationship under this case, the relationship can be monotonically decreasing until this one. So this is why you can find under when lambda is larger, when delta is larger, we can see the relationship is not monotonically or monoton. Okay, and then we can also find by this figure 2, we take the first derivative of emission with respect to lambda here. So we can find here that, okay, so we can see here the horizontal axis is lambda and the vertical axis is delta. Delta is the degree of product substitutability. So here we can see that the whole area in region here, the brown color, emission is decreasing in lambda. However, only this region, emission is increasing in lambda. So meaning that we not only have that increase in lambda reduce emission, but we can find that increase in lambda can increase emission. So we can find it through figure 2, because here we see that higher delta, higher competition, higher quantitas or quantity. But here, higher lambda, lower competition, lower quantity, right? But this one, higher delta, more competition, dominates the higher lambda, lower competition. Therefore, we can find region R2. Emission, because higher competition, increase quantity, increase emission, is increasing in lambda. Okay, so this is one of the interesting result here. So the author mentioned that there are two channels through which emission decrease: a reduced output level and increased emission abatement investment. So the increase in emission abatement investment improve the emissions of efficiency. So this example reduce the emission per output, while decrease in output does not. Okay, next, in proposition 3, we want to see the effect of or the relationship between output and lambda. So we just substitute the emission into equation 1. We can find equilibrium output in equation 7. So we can, from equation 7, we can find proposition 3. The equilibrium output level QF is decreasing in lambda. So we can prove this by appendix C. So we take the first derivative of QF with respect to lambda in appendix C4. So we can find that this is negative because, okay, this is our H here and this H is positive. So positive and positive, this one is positive. So actually the nominator is positive. This one is positive and this one is negative. So we can find that increase in lambda, decrease QF. Proposition 3 states that common ownership reduce output level, which reduce emission. Okay. We next discuss about the relationship between lambda and XF. XF is the abatement. So we substitute QF and E into the X. So we can find equation 8. From equation 8, we can derive proposition 4. The equilibrium abatement level is decreasing in lambda if lambda is this value. However, in the second point, we want to see the relationship between lambda and F if lambda is closer to 0. So if lambda is closer to 0, lambda increase the abatement if and only if delta is higher than 0.531. So actually delta is very important for this result because when we introduce delta or the degree of product substitutability, the author can discuss more about the paper. Okay, we prove proposition 4. We differentiate equation 8, XF, with respect to lambda. It's in C.5. Okay, so we can see that XF here is negative if we have this condition. So we can find that the lambda element 2 minus delta minus 2 times square root of 1 minus delta over delta. So this proof proposition 4.1. And then from the first derivative, we can substitute delta into it. Lambda equals to 0 into it. So we can find this one. And we find it positive if and only if this one is lower than 0. Okay, so proposition 4.5 suggests that XF may increase in lambda if lambda is small close to 0, whereas xf always decrease with lambda if lambda is large, close to 1. In other words, the relationship between xf and lambda is an inverted U shape and downward sloping. And proposition 4.2 states that the relationship is non-monotone if delta is large. Okay, so we can discuss about this later in figure 3. Now we make the summary. A moderate degree of common ownership may accelerate emission abatement, but a significant common ownership dampens activities. I think this is quite intuitive if we discuss about lambda and emission abatement only, because a moderate here means lower lambda can increase the emission abatement. However, higher lambda decrease the emission abatement. So actually the explanation is here: moderate degree of cross ownership increase emission abatement. So increase in emission abatement can reduce the emission. Increase in emission abatement increase marginal cost, because we need to pay the cost for abatement. And of course, this will increase the PI and PJ through the strategic interaction in the product market. So this can increase in PI, higher PI and PJ. So each firm is more concerned with the rival profit when lambda is large. Thus, an increase in lambda may increase XF, because trigger commitment raises the rival profit. And the second one, however, here, when lambda is sufficiently large, firm can cooperate without committing to an emission cap. Example, the price are close to joint profit maximize 1. Thus, when lambda is sufficiently large, the firms are more collusive. Firms avoid stricter commitment that induce a large XF to save abatement investment cost. Therefore, XF decreases with lambda is large. Okay, so and then when delta is large and lambda is small, okay, so we can explain this through the figure later. So the competition in the product market is tougher. So here delta is larger, right? Higher delta, more homogeneous the product. Okay, and then more competition. Here, competition in the product market is tougher, more increased competition. Okay, and then here, and a stricter commitment raises the rival profit more significantly. And we know that a smaller lambda, more competition, right? Because degree of common ownership is smaller. So the author says that hence an increase in lambda increases the incentive for the environmental CSR more significantly when delta is larger. Therefore, an increase in lambda increases XF when delta is larger. So okay, I think I can explain by this way. So we can see from here, this region abatement is decreasing in lambda. This region abatement is increasing in lambda. We can see this one, delta is high. Here, more increased competition because the product is more homogeneous. Okay, here less competition. Okay, here more competition. So we can see that more competition and more competition, so increase the product, abatement is increasing in lambda. So the more lambda until here, abatement is still increasing in lambda. So but the closer lambda to 1, because competition is lower, abatement is still increasing, because this, I think because this effect dominates the higher competition effect dominates the less competition. Therefore, abatement is still increasing in lambda. So it says that figure 2 suggests that emission level is decreasing in lambda for most of the region, because higher lambda reduces total output. But figure 3 suggests that this occurs because the output level decreases rather than due to an increase in the environmental investment. Therefore, common ownership, especially a large degree of common ownership, is harmful to stimulate emission abatement investment. Okay, now we continue to the social welfare implication. So we can find that social welfare is the consumer surplus plus producer surplus minus damage. So here we can substitute all the equilibrium, the result in the equilibrium into the social welfare. We can find social welfare. So here figure 4.1, it says that R is the environmental damage coefficient. So if the environmental damage is low, then welfare is decreasing in lambda, because increase in lambda reduce Q, lower consumer surplus. Therefore, and our emission is also low, so therefore this lambda will decrease social welfare. Figure 2, when damage or environmental damage coefficient is higher or high, 5/10. 5/10 means R is large. Welfare can be non-monotone, because increase in lambda, lower quantity, and lower emission, improving welfare. This welfare improving effect dominates the welfare reducing effect mentioned above when R is large. So when lambda is small, increase quantity, increase consumer surplus, increase social welfare. This welfare improving common ownership is more likely because the consumer surplus reducing effect is weaker and the welfare improving effect of reducing emission is stronger. Thus, the relationship between lambda and welfare is likely inverted U-shape when R is large. So, we continue to the concluding remarks. We investigate how common ownership affect emission level when firm can use environmental CSR as a commitment device to soften competition. So result, under a moderate lambda, emission level decrease. However, under higher lambda reduces emission abatement investment because Q is lower. Thus, common ownership, especially a significant degree of common ownership, dampen emission abatement investment. The study is innovative in the sense of that it analyzed the interaction of the three areas: environmental economics, industry, organization, and finance. So that's all about the paper. Thank you.